Our last learning target with slope-intercept form is taking a look at how to write an equation from a word problem. So our essential question is, how do we interpret word problems? A lot of students will see a word problem and not even attempt it because they think it's too hard or they think they can't do it. So we're going to practice word problems until you get comfortable with them and you get your confidence up. So we're starting off with a question about a plumber. Now, a lot of people that come to your house and work on anything from electricity to plumbing to your air conditioning, they charge a fee just for showing up at your house. And then they charge you money for each hour they work. So that's the situation we've got here. So what you want to think about to convert this to an equation of a line is we have y equals start plus change times x. Now this is a little bit backwards than the way we've been using it, but another way to think about this is you have a starting value, something that you, in this case, pay no matter what. They could show up at your house and say there's nothing wrong, and you still have to pay them for driving all the way out to your house. Plus you have a rate of change times, in this case, number of hours that the plumber is at your house. So we're going to look through the word problem. A plumber charges $25 for a service call. That's the amount that they charge no matter what. Then, plus, there's our change. One key word that you want to look for in word problems, for lines anyway, is this word per. We've been focusing on rate of change. We've been setting up lots of different rates of change, and they all have the word per. Dollars per hour, miles per hour, centimeters per second. They all have the word per. Per tells you that you're looking at a rate of change. So that's what you're going to multiply by your x. It says write an equation for the cost. Notice how C is capitalized and hours are capitalized. Those are the variables that we're going to use so that we know exactly what we're solving for when we answer the question. One way to think about that is independent versus dependent. The cost depends on how many hours the plumber is at your house. Dependent variable is the y. We had our starting value, or a service charge, of $25 plus the $50 per hour for the time that the plumber is at your house. So there's the equation of our line. Then we can use it to determine the cost if the plumber is there and works for 4 hours. So to do that, we simply substitute 4 for h and solve for c. So the cost would be the $25 service charge plus a rate of $50 per hour. After 4 hours would be $200. So the total charge that the plumber would earn for coming out to your house for 4 hours is $225. Let's see if we can do this one more time. So we're going to read through this word problem. I want you to pick out the starting value and our rate of change. Another keyword that you might see in a word problem is rate. Bells should go off. We've been working on rate of change, so our rate of change, or our slope, is half a foot per day. We get 2 keywords on this one. The water is currently, that's our starting value, 34 feet. So again, I'm giving you some different variables to use. Level of water after how many days? So we have the water level depends on how many days the water has been evaporating. We have our current water level at 34, and because the water is evaporating, I'm subtracting the half a foot per day that the water disappears from the river. So there is our equation, and then we'll use it to see how long it will take to recede. That means go down to 26 feet. Notice this time I did not give you the number of days, I gave you the water level. So we're going to substitute the 26 feet in for the water level and sub for how many days or how long it will take the river to get that low. To solve for D, we subtract 34 from both sides. 26 minus 34 is -8, equals -1/2 D. Don't lose the negative on your rate of change. Multiplying both sides by a -2 to cancel the negative and the division. we get 16 equals D, or 16 days. Now, if you lose the negative sign and you say it takes a negative amount of days, or if you didn't notice that your rate was negative in the first place and you got a negative amount of days, that should tell you that you did something wrong and you need to go back and find your mistake. When you're working with real life, we don't talk about negative days. Here's a you-try question. Find your starting value and find your rate of change, and you'll be able to set up your equation pretty easily after that.